Hello everyone, we are glad to have this work accepted at KDD 2019. The title of this paper is Towards Robust and Discriminative Sequential Data Learning, When and How to Perform Adversarial Training. This work was motivated by how to more effectively mine the knowledge from large amount of sequential data. For example, Adobe.com has huge amount of web browsing data. And by analyzing users' sequential behaviors, we can better understand their preferences and finally provide better personalized experience. And actually, we want to go one step further to provide sequence-level interpretability. Specifically, we can answer which set of events finally convert to the purchase behaviors. And one major challenge here is usually we have very few amount of labeled data, and that's why we want to augment training data. One possible way is to make the training data more diversified by replacing some browsed web pages by some other similar web pages. And one common way to do this is through adversarial training. So this basically means given a set of data points, we can apply some perturbations, and then using these perturbed data points, we can learn a very smooth classification boundary. Some previous works have shown that this method works really well in practice. But most existing works, they only focus on static data, but when it comes to the sequential data, we really have to think about when and how to perturb this sequential data. So the first question is when, and our solution is to use attention mechanism in recurrent neural network. Specifically, we will apply larger perturbations on those time steps that are more important. For example, here we show a short movie review for sentiment classification. And our method can clearly detect those words that can truly reflect the sentiment, and then replace them by some other similar words. And here's another example from Adobe.com, where our method can detect a series of tutorial web pages that finally lead to a purchase of Photoshop. And after perturbations, our method can replace these tutorial web pages by some other similar tutorial web pages. And the second question is how to perturb sequential data. Basically, we want to make sure that the sequential data before and after the perturbations have the same discriminative period. And we propose two algorithms, selective filtering and conservative adversarial training, for this issue. We evaluate our method on three types of dataset. One is e-commerce from Adobe.com, and the second is sentiment classification, and the third one is remote sensing. And we've shown that our method on all of these dataset can significantly improve the performance compared with the existing methods. We have more detailed method discussion and results in our paper. Please contact us if you feel interested. Thank you.